In this video, we're going to talk about additions and subtractions of special angles. Okay, so when you have addition and subtraction of special angles, it most likely comes in two forms. The first one, you have, say, sine x plus sine y. Okay, so probably a special angle, it could look something like this: sine 45 plus sine 60. Okay, so in this case, you are simply going to take the value of sine 45, say 1 over root 2, plus sine 60. So this would be sine 60 is root 3 over 2. Then you are going to add both of them. So if you add this would be LCM is 2 root 2 divided by, okay, then this will be 2 plus root 3 times 2. So ultimately we'll have 2 plus root 6 over 2 root 2. Okay, so for the first form, you just have a sign adding themselves up. Okay, so you take the values individually and add them up for your special angle. And then for the second case, you could have, say, something like sine 45 plus 60. Okay, but most times in practice, this will not be given in this form. So you might probably get a question that looks like sine 105. So it is now your job to break it down into simpler angles, into simpler special angles. Okay, so you could say sine 105 can be broken down into simpler special angle, which is 45 plus 60. Okay, so to solve this particular problem, you need to know the sum and differences formulas. Okay, so for the sum and differences formulas, you'd have, say, when you have a problem of, say, sine x plus y, the answer should be sine x cos y plus sine y cos x. Okay, and then the second one, when you have sine from bracket x minus y. Okay, so your answer should be sine x cos y minus sine y cos x. Okay, so when you also have in cos's, so let's say you have cos x plus y, the answer will be in cos x cos y minus sine x sine y. And then when you have cos of x minus y, the answer will be in cos x cos y plus sine x sine y. Okay, so you need to know these formulas to solve problems on this kind of form of addition of special angles. Okay, let's take an example so that you understand better. One, let's say we have sine 15. Okay, now for us to solve this, we could break down sine 15 by saying sine 15 can also be equal to sine 45 minus 30. Okay, so we can also represent sine 15 as sine 45 minus 30. Okay, so to solve for this value, we need to use the sum and difference formulas. Okay, but before then, I'd like to show you a table that contains the values of the special angles. Okay, so this is a table that shows the values of the special angles. Okay, so this table, you need to copy this table somewhere because we are going to be using them for solving problems in this video. Okay, so let's start off with this one. So from sine 45 minus 30, the sum and difference formula we are going to use here is going to be sine 45 cos 30 minus sine 30 cos 45. Okay, so this would mean that sine 45 from our table is 1 over root 2. So we have 1 over root 2 times cos 30 is root 3 over 2 minus sine 30 here from our table is 1 over 2, and then cos 45 is 1 over root 2. So let's simplify this equation more. So this would be equal to 1 times root 3. So we have root 3 as our numerator. Then for our denominator we have root 2 times 2. So this is 2 root 2 minus 1 times 1 for our numerator is 1 divided by 2 times root 2 for denominator. Okay. So if you look into this fraction, both of them have the same denominators. Okay, so that's a pass for saying that LCM is the same. So this would ultimately mean that the numerators stay the same. So we have root 3 minus 1. Okay, so that's the answer to this problem. Let's take more examples. 75. Okay, so you might want to pause the video and try this one out yourself. Okay, so like before, we could just say for our cos 75 value, we could say cos 75 can be represented by two special angles. So cos 75 is 30 plus 45. Okay, so 30 plus 45, we can use the sum and difference formula to solve this one to get an alternate value of cos 75. Okay, so sum and difference formula for this should be equal to cos 30 cos 45 minus sine 30 sine 45. Okay, so cos 30 from our table here is with 3 over 2 times cos 45 is 1 over root 2. Then I have minus sine 30 is 1 over 2, and then sine 45 is 1 over root 2. Okay, so for the numerator of this part, root 3 times 1 is equal to root 3 divided by denominators 2 times root 2 is 2 root 2 minus 1 times 1 is 1 divided by 2 times root 2 is 2 root 2. Okay, so this is equal to root 3 minus 1 . Okay, so for this case, you can pause the video and try this one out yourself. Okay, so like before, we find two special angles that can add up to this value. Okay, so for this case, we have sine 60 plus 60. Sine 60 plus 60 does the job. So we are going to take the sum and difference formula and use it to solve this problem. Okay, so this would be equal to sine 60 cos 60 plus sine 60 cos 60. So in the end, this is equal to sine 60 is 1/3 over 2, cos 60 is 1/2, plus sine 60 is still √3 over 2 times cos 60, which is 1/2. So the numerators here, √3 times 1 is still √3. Denominators 2 times 2 is 4, plus numerators here is √3 times 1, which is still √3, divided by 2 times 2, which is still 4. And then for the LCM, we have the same denominators, so this would be 4 divided by, we have √3 plus √3. So √3 plus √3 is ultimately equal to 2√3 divided by 4. So we know that 2 can go into itself once and 2 can go into 4 twice. So this is ultimately equal to 3 over 2. Okay, so that's the answer. Let's take another problem. For sine 90, you can pause the video and try this one out yourself. Okay, so for sine 90, we're still going to take the same approach. So it's still going to be equal to, break it down into special angles. We have sine 45 plus 45. Sine 45 plus 45 is sum and difference formulas. We get sine 45 cos 45 plus sine 45 cos 45. Okay, so this would look like, say, equal to 1/√2, that's the value of sine 45, times 1/√2 for cos 45. So we have plus 1/√2 for sine 45 times 1/√2 for cos 45. Okay, so we're going to be multiplying the numerators to each other. So this would look like, say, 1, denominators to each other, √2 times √2 is √2 squared, plus 1 times 1 is 1, divided by √2 times √2 is √2 squared. Okay, so we know that square can cancel out square root, square can cancel out square root, so we have 1/2 plus 1/2. So LCM here is simply 2, and then we have 1 plus 1 for the numerators plus 1, so this is equal to 2/2. 2 divided by 2, 2 into itself is 1, 2 into itself is 1, so we know that 1/1 equals to 1. So this simply means that the sine of 90 has a value of 1. Okay, 30 plus sine 30. Okay, you could just simply do the addition manually by saying, okay, sine 30 is 1/2 plus sine 30, which is 1/2. So this is equal to half plus half. Here is 2 divided by 1 plus 1, and then we have 2/2. So this is equal to 1. So when you have the signs different and an addition sign between them, you simply just add them up by picking up their value and doing it like normal additions. Okay, so let's say we have tan 60 minus sine 40. Okay, so this would look like, say, equal to 45 sine 45. This is look like, say, equal to tan 60 is √3 minus sine 45 is 1/√2. Okay, so the LCM here is divided by over 1. We have √2 divided by Root 2 divided by 1 is root 2 times root 3, so we have root 6 here, minus 1. So this is the answer to this problem. Okay, so note that this form is applicable for mostly special angles. Okay, thanks for watching the video. If you liked the video, share with your friends and subscribe. Thanks for watching again.